3 or 4 already. Okay. Yeah. Okay. For exercise 3D, any issues regarding question 8? Question 9? 9? What is the issue with question 9? Part 3, I want you to write it yourself. Okay, write yourself. Okay, question 11. 11, any issues? 13. Okay, I want you to practice writing your statements, so I don't want to go through them until I mark, then I give feedback. Okay, no issues, then pass your homework down to the front. Copy it or anything. Exercise 3D. I realize your classroom is extremely warm. I think it's because of that, right? The aircon compressors. Why? Because COVID. Yeah. Huh? Yes, Bernice. Sorry, say again. Tomorrow. Okay. You're getting back to us, huh? Okay. Oh, lunch. Alright, let's continue with our matrix multiplication. Okay, so yesterday I gave you this question and asked you to go and figure it out in terms of the multiplication. Okay, so could I just get answer from one person? Let's see. Jiyang, can you tell me what is your answer? Left to right, first row. 70, 1. Then, negative 12, negative 52. Okay, let's get another person. Teresa. Negative 80, 15, 55, and then one more person. Let's see. Answer? Answers? Sorry? Oh, okay. Tell me the fun answer, can, rather than the working. What would it be? You do? Haven't finished? Okay, let me get another person. Noe. Sorry? 0. Then Negative 63 followed by 153. Okay, Dylan, could you please reduce your talking sound? Okay, so if you recall, yesterday I said that we take the row here, multiply by the column here, okay, component by component, then add different components together. Okay, so multiply first, then add. So therefore, 4 times 2 plus negative 9 times negative 7, okay, will get you 71. Alright, then for the second space over here, it is located in the first row, second column. So we go for first row, second column, 4 times negative 3 plus negative 9 times 0. Therefore, I get negative 12. Okay, so the answers here is correct. Do check what you have with the answer here. Okay, yeah, so let's look at another one. Okay, we have here 2, 3. Okay, for one matrix, then the other matrix I have 7, 8, negative 9, 4. Right? What is the order of this first matrix? Chloe? Order? Say again. 2 by 1. Okay, so Chloe says this is a 2 by 1. How many of you agree or disagree? Anyone? Emily, so you disagree? So what should it be? 1 by 2. Okay, so remember, row first, then column. So it should be a 1 by 2. Right? Then in the next one, this is a square matrix, so it's a 2 by 2. Okay, so you should realize that if you had 2 by 1 over here, and this one is definitely 2 by 2 only, then the middle numbers actually do not match up, right? Therefore, it will not be computable. Then you will have trouble in getting your answer. So in this case, with a 1 by 2 and a 2 by 2, our final matrix, what order should it actually be? What's the order of my final matrix going to be? Sorry? 1 by 2. Okay, so 1 by 2 matrix, 1 row, 2 columns. Okay, so could you give it a try? Tell me what is the answer. I'll give you 2 minutes. If you're fast enough, you can try part D and E. Okay. So for part C, what is the answer? Wait, can you tell me what's the answer for part D? Sorry? part C, I mean. I'm sorry. Negative 13 and 28. Do we all get that? Okay, negative 13 and 28. Sorry, this thing is blocking. So I'm trying to prepare a visualizer for it. Is it still there? No. It's still there. Okay. Next, we look at part D. Alright, let's take a look at part D where we have 7, 8, negative 9, 4, and 2, negative 3. Okay, something similar to part C, just that we shift the matrices around. So instead of the square matrix on the right, we have it on the left now. Okay, so this one, the order is 2 by 2. This one is a 1 by 2 matrix. Okay, now, is this solvable? Alright, it's not solvable, right? Because the number of columns here and number of rows here are not equal. So therefore, not possible. Okay, yes, Joseph? Sorry? Can we bring it over? You can't. Okay, because I mentioned already, in matrices, A times B does not equals to B times A. Alright, so 2 times 3 and 3 times 2 in numbers form is correct. Okay, so you can do that, but then when it comes to matrices, we cannot do that. Why can't I switch this off? Okay, next we look at part E. Alright, for part E, what is the order of this matrix here? Zhen Quan? 3 by 1. And the matrix on the right, what do you have? 1 by 3. Okay, so the matrix that I'm going to get at the end, what will the order be? Alia? 3 by 3. Okay, so could you give this a try? Try to figure out what are the elements found in this matrix. Give you 2 minutes as well. So what's the answer for part E? What do you get? Wait, what do you get? First row, 49, 14, sorry, 21, so 49, 14, 21. Okay, then after that, what about in second row? Joshua? Negative 56, 16, 24, right? And Dylan, last row, 35, negative 10, and negative 15. Okay, is this answer correct? What's wrong? Should be negative 49 because 7 times negative 7. Okay, so should be negative 49. Alright, so this should be the answer when it comes to the matrix multiplication for these matrices. Next one, okay, part F. Alright, and so why not you give this a try? Can you tell me the order for this matrix? 1 by 3. Okay, and 3 by 1. And your N matrix will actually be a 1 by 1 matrix. Good. Okay, so how are we going to get this 1 by 1 matrix? Anson, continue. We only got one thing. Negative 7 times 7, followed by plus 2 times 8, plus 3 times negative 5. Okay, so take this times this, this times this, this times this, and you will be able to get negative 48. Okay, very often when we get a 1 by 1 matrix, students tend to forget the brackets. Okay, and that will immediately be wrong because this bracket is essential to tell us that we are getting a 1 by 1 matrix. If you have it without the brackets, it doesn't make sense at all because two matrices, when they multiply, they cannot give you a number, a scalar number on its own. Okay, so we need to have the matrices, the brackets itself. Okay. Next, moving on to our exercise 4C question 5. Okay, give me a minute to set up the visualizer. Okay, turn to your textbook, exercise 4C. That's on page 149. Because the question is fairly long. Okay, maybe I also just want to point out while we wait, right? Part E, notice that the matrix that we are multiplying is actually quite similar. It's actually the same one as we have in part F, but when we actually shift it around, notice that the answer is totally different already. Okay, this one we get a 3 by 3 matrix. This one we got a 1 by 1 matrix. So that's why, okay, when it comes to matrix multiplication, you cannot just flip things around because the answer will not be the same. Okay. The visualizer work this morning. Oh, okay. in dollars charged by 3 childcare centers is expressed in this matrix. We want to find the annual fees charged by each of the childcare centers, giving answers in matrix form. Okay, so how do we go about finding out this matrix? What would you do, Shami? This is for per month. We want to find annual. We just times 12, okay, so we can consider the matrix 12C to represent a matrix for the annual fees of each childcare center. So that would tell us that we have 12 times this matrix here. Keying it individually into the calculator. We get 8160, 8640, and 7620. Alright? Okay, in part 2, we want to evaluate 12C plus J plus D, whereby J is the matrix for some special program, and D is also a matrix for another special program. Okay, so could you do a quick calculation for 12C plus J plus D? Give you just 2 minutes. If you're fast enough, you may want to start thinking, what does this matrix represent as well? Try to think about it in your own words. Okay. Right, so Joanne, may I know what is your matrix that you got? 8490. Sorry? 8910. 8020. Okay, do we all get that? Right, so if I want to write this, express this matrix in terms of words, okay, tell the reader what does this matrix actually represent. How will you go about describing it? Okay, how would you go about describing it? Amanda, what do you think?
Represents the annual fee, including the additional cost for special programs for each childcare.
Okay, so Amanda says it represents the annual fee, including sorry, what again?
Additional cost for special programs.
Additional costs for special programs for each childcare center? Okay, do we all agree and accept that this is a good answer to actually explain the matrix? Okay, so 12C was looking at the annual fee. J is looking at the additional cost for June programs. D is the cost for participating in the December programs. So we see that there is this annual fee being mentioned, and then the additional cost for the special programs being mentioned as well. Okay, then for each childcare center, which is also true because we are breaking it down to each childcare center. Alright, so I think that this is a sufficient explanation to describe the matrix itself. Alright, anybody has a second opinion? No? Okay. Then next, look at part 3. In part 3, it says that Mrs. Yeo wants to enroll her son in one of the childcare centers, and she is interested in the June special. Okay, June special programs only. Which childcare center charges the lowest fees? So in order for us to be able to compare, we got to find out what is the cost going to be like annually, including the June fees. So we will find out what is 12C plus J, and that will be our, hang on, 12C we got 8160, 8640, 7620, plus J will be this. So that leaves us with this matrix. Okay, and looking at the elements in the matrix, we can tell that childcare center Z offers the cheapest fees. So therefore, Mrs. Yeo should choose childcare center Z. Okay. So to answer the question on which childcare center charges the lowest fees, we just say childcare center Z charges the lowest fees. Okay. I want to introduce to you a very special matrix, and that is very important. Okay, and that is the identity matrix. Okay, the identity matrix itself is usually a square matrix. Okay, so it comes in different forms. Okay, so we will have our 1001, which is a 2 by 2 matrix, or a 3 by 3 form, which is a 100, 010, and 001 matrix. So we notice that the diagonals, okay, will always be 1. Right, Joseph, could you please wake up? Okay, the diagonals will always be 1. Alright? Then the rest of the elements found in the matrix will have to be zeros. Okay? Alright? Diagonally must be from left to right, cannot be from right to left. Okay, what's so special about this identity matrix? So if you were to look at question 9, given A and I, we see that AI itself when I multiply it together, okay, this is a 2 by 2 matrix, 2 by 2 matrix. My answer will still be a 2 by 2 matrix. And if I take 8 times 1 plus negative 3 times 0, I will get 8 over here. Okay. Second input, 8 times 0 plus negative 3 times 1. I will have negative 3. Next one, 7 times 1 plus 5 times 0. I get a 7. And 7 times 0 plus 5 times 1. I will get a 5. So I see over here that when I multiply by an identity matrix, the matrix remains the same. Okay, which is essentially A itself. Right? Now what if I flip it around? Because just now we saw that if I were to flip it the other way around, okay, the matrix I'm getting is different. So if I were to look at IA, okay, I am still going to be getting a 2 by 2 matrix because this is 2 by 2, 2 by 2. Final one will be 2 by 2. 1 and 0 corresponding to 8 and 7. 1 times 8 plus 0 times 7. I will get an 8. Next one. 1 and negative 3 plus 0 times 5. I will have a negative 3. 0 times 8 is 0, plus 1 times 7, I will have a 7. 0 times negative 3, plus 1 times 5, I will get a 5. So, matrix still remains the same. So, our identity matrix, okay, in conclusion, the function of it, okay, is to ensure that our matrix remains the same at the very end. Okay, so it is like how we have a times 1 in our number system. Okay, because 2 times 1 is 2, 3 times 1 is also 3. Alright, so our identity matrix serves that purpose. Okay. Okay, so it behaves like a times 1. Right? You need to know what is the identity matrix. It is not all the time that they will tell you that I is actually 1001. You need to be able to give a suitable identity matrix itself. So let's say if I say A is maybe 3 times 5, 3 by 5 kind of matrix, then what is the identity matrix that we are going to have? Okay, it will have to be a 5 by 5 matrix. So just an example. Okay. If I were to look at, let's say, A to be a 3 by 5, okay, maybe don't want 3 by 5. Do we really want a 3 by 5? Okay, let's go for a smaller one, 3 by 2 matrix. 2 by 3 matrix, okay, 2 by 3. Okay, can you give me any random numbers? 2 by 3 matrix. Random number, give me. Any number? Sorry? 66. Do you see that? 6. Oh, 6. Okay. Next one? 7. Okay, so? 8. Not very simple leh. Next one, Amanda. 6. Joshua. Give me another, any number. 9. Last one. Chloe? Really? Just any number, you don't even give me a decimal, you don't give me negative integers, no fraction also. Change the 6 negative, okay lor, okay. Yeah. Okay, so 2 by 3, alright? And then they tell you to go and find out what is AI, okay? Not artificial intelligence, Right, so AI will have to be, okay, so they may not actually tell you what is I going to be. So you need to be able to know. And in order to get the I, okay, it must be a 3 by 3 matrix because it must correspond with this number of columns here. So our I must be a 3 by 3, so 1 0 0 0 1 0 0 0 1. Okay, so if I were to multiply these two matrices, right, to save the space, I will not write that down. Okay, so I take 6 times 1 plus 7 times 0 plus 8 times 0. So these two inputs become 0. So I will be getting a 6 over here. Okay, so 2 by 3 and 3 by 3, I will eventually be having a 2 by 3 matrix in the end. Okay, so next input, I will have 6 with 0 is 0, 7 and 1, 7, and 8 and 0 is 0. Okay, so if you were to continue with this, you will find that your matrix will still remain the same. Okay, so that is the whole purpose and whole idea of identity matrices. Okay, we do need it sometimes. Okay, offhand I can't quite remember. Okay, under what situations will we be able to require it, right? But knowing the identity matrix is important. Okay. Then another important thing that I want you to be able to recognize is, for example, if I ask for a matrix A squared. Okay, what is our understanding of A squared in our algebraic terms? A times A, right? So in our matrix terms, it also means A times A. So if I will just take this matrix here, we are multiplying two matrices. Okay, so why do I have to emphasize on this? Because, okay, if you don't capture what I say now, likelihood you take the square, you go and square every single element. Okay, please don't do that, right? A square means A times A, so the matrix A times the matrix A. Then we do our usual matrix multiplication, which is 8 times our 8 plus negative 3 times 7. Okay? Yes?
A cannot be like a 2 by 3 matrix.
A cannot be a 2 by 3 matrix. Okay, so good question. Didn't ask. If A is actually this one, can we get A squared? Right? Because if I do A times A, this is 2 by 3, this is 2 by 3. I will not be able to deduce something because the numbers here are not equal. Okay, so this one not possible to evaluate. So usually we can only get A squared only under one condition. That is that the matrix itself is a square matrix. If it is not a square matrix, then I cannot get a A squared at all. Okay? So continuing to calculate this, I will get 64 times plus negative 21, 43. Okay, so this will be our answer for A squared. Yeah, Zhen. Sorry? Need to, right?
Can you divide a matrix?
Divide a matrix, okay? Good. So we cannot divide matrices at this point. Okay, so because we see that when we do our multiplication, it is in a different form already. It is not the intuitive whereby I take this number times this number. Right? So therefore the division itself is not going to be natural as well. Okay? Although when you go up to high levels, okay, the idea of division, okay, is actually introduced when we understand this thing called determinant. Okay? Yeah, determinant, right? I think so. Sorry? Why? Yeah. So, sorry? What thing? Okay, so we are not going to be looking at division, okay, at our level. Okay? Okay, so that's all for 4C. What time of lesson end? 3 o'clock, okay. Save your what? After this is history, okay lah. Okay, sis, actually we don't have a lot of time. I got one more chapter, chapter 5. Let's see, Okay lah, 15 minutes. Okay, exercise 4C, homework, you can do it now. Okay, I won't go into, you want you can do this or else you can do your 4B also can. Okay?
So we cannot do history.
No, cannot do history. You should have studied before that. What? Okay, you can spend the remaining time to do your homework. Okay? Off the video, can?
Where's the due date?